solving some half-life type of problems. So here we go. If the math seems a little bit difficult, don't sweat it. Just use a chart like this where you make some columns, label one as cycle and whatever else you're trying to solve for. Now the key is the cycle number that you always start with. This never changes. So your information always starts with cycle 0. This is before any half-life processes have occurred. And you just number in order. So cycle 0, 1, 2, 3, right? So it asks us what percentage of C14 sample will remain at the end of 3 half-life cycles. So before any cycle occurs, 100% of the sample is radioactive. So at cycle number 0, before any cycles have occurred, the percent of radioactive sample is 100. And then from there, it goes from 100% down to 50%, and then it's cut in half again at the end of the second cycle, 25%. Then at the end of the third cycle, the sample is only 12.5% remains radioactive. So here it would be 12.5%. So take a look here. It says determine the number of half-life cycles that have passed if only 12.5 grams remains of a 200-gram sample. Well, I'm going to start with my cycles. I know that I always start with 0 cycles, and then I'm just going to put them, number the number of cycles. Will I need all of these? Probably not. So the other piece of information that I noticed in the problem is that I'm given 2 different masses. So this is what remains. So this must be, since it's the smaller mass and it says remains, this must be where my data ends, and this is where it started off, remains of a 200-gram sample. So this is the mass that I start with. So this is the mass that I put at 0 cycles. I start off with 200 grams. And now I'm just going to work my way down. So 200 grams, only 100 grams remains radioactive through cycle 1. I'm going to go to cycle 2. Now only 50 grams of the original 200 remains radioactive. At the end of the third cycle, only 25 grams of the original 200 remains radioactive. At the end of the fourth cycle, now only 12.5 grams of the original sample is still radioactive. So now this is the end mass. This is where I needed to get to, and to get there, it required 4 cycles. The next question asks, determine the amount of time that has passed if each cycle requires 12.3 minutes. So here is the thing. You don't need to write all this out, but make sure you understand it. So to go from 0 cycles to 1, that was 12.35. To go from cycle 1 to cycle 2, that's another 12.35. To go from cycle 2 to cycle 3, that's another 12.35. And to get to my fourth cycle, from cycle 3 to cycle 4, that requires another 12.35. So to do this math, it would be 4 times the 12.35. So in the end, the amount of time that has passed would be 49.4 minutes. Or you could simply add those all up.